Hi everyone, welcome to class number 2. In this class, we're going to build our very first ComfyUI workflow from scratch. And as we do this, we're going to look at the different components that are the basic building blocks of the Stable Diffusion workflow. So we need to start with a model that was trained to generate images. This type of model is called a checkpoint model. And we can go to the manager and go to the model manager. And what we see here is a pretty big list of a lot of different models. Now, many of these are not checkpoint models. So we can narrow down the selection by going to type and selecting checkpoint. Now, we're really only interested in one model from this list because the other three that we're going to use in the course, we're going to download them elsewhere. They are not on this list. And the model we're looking for is called SDXL. We can just type the name here, and now we get all the different variations of the SDXL checkpoint model. We're gonna want to load the turbo one, and you see that there's two options, a regular one and FP16. FP16 options, whenever you have them, I recommend using those because they are smaller, faster, and work a lot more efficiently with most consumer GPUs. If you have a really, really extremely strong GPU with lots of memory that you can use the other ones, but for all practical purposes, I would recommend always going with an FP16 if you have that option. So all you need to do is click on install. You see here in our log that it's loading the model. This may take some time because checkpoint models can be pretty big, several gigabytes. All right, so the model is downloaded. We can click refresh, and that's it. So SDXL is a very versatile and fast model, but it's not necessarily the best at creating photoreal imagery. And I think that if you're using AI in the context of visual effects, you're most likely looking for models that can produce realistic images. So I've played quite a lot with different models, and there are three models that I think are the best at consistently producing photoreal imagery. These are not offered in the manager, so we have to go and bring them in a different way. And there's mainly two ways to download different models for Stable Diffusion. The first option is Hugging Face. This is a huge repository of models, and you can most likely get anything you need right here. You can type the name of the model. So we're going to start with one of my favorite models, Analog Madness. And that takes you to the models page, and you want to go to files and versions. And the file you usually need only one file. It ends with a Safe Tensors extension. So there it is right here. You can just click here to download it. All the checkpoint models need to go into the checkpoint model folder. So you got to go to, if you're installing them manually like we're doing right now, you got to go into your ComfyUI folder and go into models and look for checkpoints and put your model, simply copy it here. So the other place where you can get Stable Diffusion models is called Civit AI. It's it's a lot more lively, as you can see, than Hugging Face. If you can stomach all these images, you'll find probably what you need here, and sometimes also more information that you'll find on Hugging Face. So the other two models we want to install are Realistic Vision, which happens to be right here, the first one that I got on the list, but you can also search for it. And the third model would be Cyber Realistics. So when you go to a model, usually the files would be right here. And you can see here that you have and FP16 and FP32. So choose the FP16, download, and place it also in the checkpoint folder in your ConfUI directory. All right, so I recommend restarting ConfUI after you manually install models. And now we're here and we can load our checkpoint model. For this, we'll need a loader node. You can search for nodes here in the Nodes tab. So let's go to Loaders. And the first one is the one we need, Load Checkpoint. The nice thing here is that you can hover over every node name and see a preview of what it looks like. So we can load it here. The other way to load nodes is to double click in the viewer and type or start typing the name of the node, and it will show you everything that has that string in it. So here we go. Now, if you click inside here, you can see, you should be able to see all the models that you've installed. So we have the Cyber Realistic, SDXL, Analog Madness, and Realistic Vision. So now that we have a model, the next thing we need is a clip. A clip is the text prompt. So this time we're just gonna double click here and type clip text and code. This is where you write your prompt, and this outputs a conditioning that goes to the sampler, which we'll look at in a moment. We need to connect the clip to the model. So we're going to use two prompts, a positive and a negative. So we can just Control-C, Control-V this. So we have two clips. And we haven't input any text yet, but we'll do soon. The main part of the workflow is the sampler, or denoiser as it's sometimes called. The sampler takes the information from the checkpoint model and from the prompts that we put in and takes a latent noise and converts that latent noise into a latent image. So latent space is an internal space where all the AI thinking and generation goes on. We can't see it. That's why it's called latent. It's not pixel space. So we can't see the latent noise. And when the sampler creates the image, until we decode it, we can't see it as a pixel image. So let's add a sampler. We can go to sampling here. You can see that in custom sampling, you have many different components of the sampling, which we'll talk about some of them, schedulers, samplers, and so forth. We're going to use a sort of a combined simple sampler that has everything already built in. It's called the K-sampler. And you see that it has several inputs. So first of all, it needs an input from the model itself. Now, you can see that inputs and outputs are color-coded, which kind of helps a lot in knowing what to connect where. Another nice thing is that you can, if you don't know what exactly should be connected to an output or an input, you can just drag a connection and then release the mouse button, and it will give you the options of what should be. So basically, these are all nodes that have the same type of input in them, latent. You see that pink one here in this case. So a lot of times, if you're not sure, you can just use that method to kind of figure out what should be connected where. All right, so we can connect the conditioning, our positive conditioning to the positive input and the negative one to the negative input, and we can connect the model to the model input. Now you see that we're missing one input here. This is the latent image, or basically the latent noise. This is the noise that from which the image is created, and this noise also defines the resolution. So we can search for an empty latent. That's what we need, which is just noid, empty latent image, and connect it to latent image. Here we set the resolution. For now, we'll leave it at 512. Now, a latent image doesn't have to be only noise like we're using. It could be another image, in which case we're talking more about inpainting or other techniques. For now, we're starting from scratch, so we're using an empty latent image. All right, so up until now, we've got everything in latent space. To see the image that we create, we need to decode that latent space into pixel space. So we need a decoder. And this is what we need, the VAE decoder. So the VAE is the decoding method that is based on the checkpoint that we're using. So each checkpoint will provide a slightly different VAE, so a slightly different way of decoding the latent image. So we need to connect the checkpoint model's VAE to the VAE input here in the VAE decode. And then, of course, our latent image goes into here as samples. And this will output an image. To see the image, we can just use a preview image node. And connect it. So now basically we've built our first workflow and we can now test it. Let's start with a simple jungle image. So in the positive text, let's type in lush tropical jungle. Let's say hanging vines, moss, wet ground, or let's say muddy ground. Scattered fog. And then in the end, I'm adding photo and realistic. And that is just so that our prompt drags our model towards a more photographic look. That means the model is using as reference, so-called reference, whatever photographs it has been trained on, rather than anime or cartoon or illustrations. To strengthen that we want something that feels photographic, we can use the negative prompt. So in here, we can put the stuff that we don't want it to look like. So I'm writing CG and render because I don't want it to look like a CG render, basically, and illustration. That should be enough for now. Here, let's choose Analog Madness as our checkpoint model. And here, for now, let's put for steps 25, and we're going to look at each one of these and see exactly what they do. Let's change the CFG to, say, 5. And let's change our sampler name from Euler to DPMPP2M. Sorry, I know it sounds it sounds very technical. We're going to go over these too. And the scheduler type to Keras. And the noise should stay at 1. And now we can run a test. You can click on the run button right here, or you can use Control plus Enter. Now it shows you the process, which node is thinking right now. This is going very fast because we are at a low resolution. And this is the first image we got. We got a jungle, we got hanging vines, we got fog, we got wet ground, everything. So before we continue, one nice thing you could do in ComfyUI is you can save a group of nodes or an entire script as a template. And that way, next time you want to start something, since this is the basis of creating images and you're going to use it even in much more complicated workflows, you can just select everything and save it as a template. To do this, if you hold Control while dragging the mouse, you're going to marquee select. You can right-click over it and go to save selected as template. You're going to give it a name. So let's call it starting point and confirm. And then next time you start a script and you want to bring that template in, you just right click, node templates, click on it, and you should see it right there. And that will bring the same template. So I'm going to delete this for now. Now, the first parameter we need to look at is the noise, seed, and control, which are right here. So by default, the case sampler is set to randomize, which means that every time you click this button or press Control Enter, it will choose a random number here, which will change the noise pattern. When the noise pattern changes, the image changes too. Part of the work of any AI, any generative visual AI is to run several variations and to choose the best one. Like here, I'm not crazy about this kind of something that looks almost like a wall here. This is supposed to be a jungle. So this could just be, a random iteration. I can go again and we'll get a completely different image. Now we don't have the wall, we have a sort of a path. So every time you run the generative process, this one even added some structure here. We didn't ask for it, but it came. So you'll get those different variations. There's many times where you actually don't want it to regenerate the noise. You want to stay with the same noise because you're tweaking other parameters and you want to see how they're affecting the image. So in that case, you set this control to fixed. You can also increment or decrement, which means that it will go up one digit on this number. I don't see this to be very useful since every different number is completely different. It's not like if you have a number that's up by one, it's going to have this similar characteristics. But fixed is very important because now every time we generate an image with the same checkpoint, it's going to be the same image. And if I try to run this again, it just doesn't run because there's no point in it. But we could use this. That's actually a nicer image. We could use this to actually compare between the three checkpoints that we brought in. And there is a reason why I want us to do it, which I'll show you here. So we already have the Analog Madness version right here. And if you click here on Q, you can see all your previous images that you created. I've got some stuff from earlier on. So let's just remove everything here so we can clean this slate, rerun this. And so we have this image. Now we're going to switch from Analog Madness to Cyber Realistic. We are on a fixed noise. So here's the Cyber Realistic version. And you can already see how similar these two images look. And now let's try the realistic vision. Here. So these two, they all look very similar. And this is not a surprise. These models are all, let's call them cousins. They're all based on the same SD 1.5 or Stable Diffusion 1.5 model. They were trained slightly differently, but there's a lot of things that are very similar about them. So the reason I have three is because sometimes a certain image or a certain request works better with a different model. The other thing to note is that Realistic Vision, unlike the other two, treats CFG differently. And now maybe it's a good time to talk about this, the CFG. So CFG stands for Classifier Free Guidance. It's a parameter that allows you to control how much the model is trying to follow your prompts precisely versus the model taking the liberty to just make a nice image. And it's a very important parameter to control. So at the lowest numbers, the model may not really respect all your prompts, but it will usually create a more realistic image. Whereas the higher you go on the CFG, the more the prompt will try to give you everything you asked and then some, but will also create a much more saturated and, let's say, plastic looking or artificial looking image. And it will also treat some of the subjects in your prompt in maybe an exaggerated way. So choosing the right CFG is a kind of a trial and error. It depends on the model, depends also on your prompts, and depends on what you're trying to achieve. But just in that comparison that we did, you can see that the realistic vision version is a lot more, say, saturated, plasticky, and looking artificial versus the analog madness and cyber realistic versions. And that's because the realistic vision model is a lot more sensitive to CFG numbers. So you really need to like go lower on the CFG to get a result similar to what we got with 5 in these two. So let's make sure we're still in realistic vision. Now we're still using a fixed seed, so we're still going to get the same image, but we're going to reduce this to 1 and run this again, and let's see what we get. So immediately you see the difference between the two images. This was looking almost like an illustration or like a cartoon animation, whereas this feels a lot more realistic. But if we try the same CFG with, let's say, Analog Madness, it will still give us a jungle, but it will feel almost desaturated and maybe even faded. So you see that the CFG number doesn't necessarily work the same for every model. Like if we stay in Analog Madness and we'll change these to, let's say, 7, you know, we're back to something that almost looks like the realistic vision at 5. It's already starting to get kind of accentuated and maybe overly done and unrealistic. If we change this to, say, 17, yeah, now we're getting something that feels kind of awkward and weird, and because it's trying so hard to give us the vines and the wetness and the fog and everything in together, but it's really exaggerating the features and the colors. So usually the range of CFG would go between 1 and, say, I know, 12, depending again on the image. Sometimes you're looking just for something like this. You see, this feels very realistic, feels more like camera footage than the others. Sometimes going so low, depending on what you have in your prompts, will get you an image that looks nice but doesn't really respect your prompts and doesn't give you what you asked for. So always play around with the CFG, but don't forget to put your noise generation to fixed so that you can compare apples to apples. All right, so the other parameter is steps. Right now it's set to 25. So the idea of steps, this is very similar to sampling levels or sampling iterations in CG rendering, because we start with a noise, and then with every step, we iteratively rearrange the noise until it looks like an image. So if you use not enough steps, you're going to get an image that's more noise or that looks very, very crude. But if you're setting the steps too high, at some point for every iteration, the changes are going to be so minimal that you're just wasting time, because the higher the steps number, of course, the slower the generation. So just to see where we're at, let's go back to a normal CFG here. Let's put it at 4. And let's start with 1 step and see what we get generated. So with 1 step, we get this, which is a blob of noise. If we change this to 2 steps, sorry, with 2 steps, we still are in the area of the noise blob. Let's set it to 3. And we're starting to get some kind of shape. 4. Big change. 5. Okay, the composition starts to appear. 6. Okay, and let's jump a little further and put it at 10. So now we already have an image. It's just a little crude in terms of the detail. So if we change this to 20, we're getting a lot more fine detail. But then if we change 20 to 30, you can see that we're now going slower, of course. And you see that the difference between the two last images, let's look at them here, is almost negligible. So I recommend not playing too much with the steps. I usually set it between 20 to 30. Again, depending on the models and also depending on what you're doing. So if you're testing some images and you want to run them faster, do 20. And if you want to go to final, do 30. But generally, unlike the CFG, which you tend to change all the time until you get what you want, the steps stays pretty much the same. So last thing in this class, as I promised, we'll talk a little bit about the sampler and scheduler. In some other applications, they even get bound together, like in Invoke AI, that's just one parameter. There is a huge list here of different samplers, and it's almost impossible to tell anyone which ones to use because that really depends on the style you're working on, what you're outputting, what models you're using. These are basically different mathematical algorithms that relate to the conversion of the or rearranging of the noise into images. So by choosing different options here, you'll get slightly different images or output. And based on my experience, where I create or generate mostly photographic or photoreal images as opposed to stylized or illustrated. The samplers that work the best for me, the options that work best are the DPM-PP2M or the SDE or the DPM-PP3M SDE. And for scheduler, I almost always use Keras. So you can follow my recommendations here as you do the course, but of course, feel free to experiment with different samplers and schedulers and see what different results you get. In the end, it's up to you what to use, depending on what you are aiming for. So this is it for this class, and I'll see you all in the next class.